Okay, so figure out if the view is nice from there, and we'll modify next time. But yes, this is Math 391, differential equations, or methods of differential equations. Typically, if you're an engineering major, you should be here. Also, physics majors would be required to take this class. Also, it's actually not a strict requirement for a math major, believe it or not, but it's okay if you're here if you're a math major. Differential equations are actually pretty important, and they have a lot of applications, which, as we go through the semester, we will talk about some of them, but mostly this class is, so it's Math 391, and it's going to be the methods of differential equations. The emphasis here is going to actually be on the methods. So this is not going to be a theoretical class, it's going to be very computational. Most of the time, I'll just be telling you about different kinds of differential equations and then telling you how to solve these differential equations. And you go forth, and for whatever reason you might need to actually use them or solve them, you can therefore learn to solve them. We will mostly be focused on ordinary differential equations. Differential equations, I'll abbreviate with DE a lot of the times. Ordinary differential equations, I will abbreviate by ODE. I'll talk a little bit about, or maybe not just, why not talk about what those are now. So we'll go into a little more detail here pretty soon, but what a differential equation is, it simply is an equation that involves derivatives. And that's it, right? It's nothing more complicated than that. We have an equation and there's a derivative in the equation. This is called a differential equation. So an example, something like, I can give you an equation, y prime equals 3x plus y. Here's an equation, there's a derivative there, it's a differential equation. I can also give you an equation, something like the partial of y with respect to x plus partial of x with respect to y equals 3x. That's also a differential equation. And whenever you have ordinary derivatives, in fact, what I mean by that is derivative of a function of a single variable. We call that an ordinary differential equation, so this is called an ODE here. If partial derivatives are involved, it is called a partial differential equation, so that's called a PDE. Most of our focus is going to be on ODEs. We will touch on PDEs a little bit in the end, but most of our focus is going to be on solving ODEs analytically. So we're going to talk about the methods to solve equations that have derivatives in them. So the goal for the class is to learn how to solve analytically a variety of ODEs. So like I said, it's not going to be very theoretically heavy, so it's mostly going to be talking about methods and strategies for attempting to solve ODEs. And so at any given time, I don't really expect this to happen, but we'll talk about it later on, I guess. But at any given time, if you feel overwhelmed or things aren't going so well, just remember that the only thing you care about is learning how to solve these ODEs. So at any given time, whatever I'm talking about, you can just pay attention to two things and ignore everything else I say for the purposes of this class. What kind of ODE am I looking at, and what is the technique to solve that ODE? Pretty much nothing else is going to be relevant for this class. I'm not going to ask you to prove anything. more or less, or I might not even prove much myself. I might talk about some proofs or some intuitions or some ideas that goes into solving certain ODEs, but for the most part, it's just going to be a solving class. And in that sense, the feel of this class is going to be like Calc 2. So I don't know if any of you like Calc 2, but that's kind of going to be the feel of this class. So you know when you're in Calc 2, you just learned a bunch of different methods. Oh, here's integration by parts, here's partial fractions, here's trig sum. And a large part of what you did in Calc 2 was just look at the integral, figure out what technique applies to that integral, and then apply the technique. This class is going to be very similar to that. So there's another class that is closely numbered to this one called 392. That one's a lot more like Calc 3, but this one is going to be a lot of Calc 2. In fact, a lot of the kind of math that we'll be doing will be Calc 2. A lot of times we're just going to be integrating and differentiating functions of a single variable. So if you're good with that, you should be good with this class. Now, I do want to get into the class, the actual specifics of how the class is going to be run, but maybe at this point what I want to do is provide a little bit of motivation. For why you should even care. Why do you care? Differential equations are super important. And are often unavoidable. It turns out that there are many things that we can discover about the natural world that the best way to express these would be to express them in terms of a rate of change. To give you a concrete example, which we're going to talk about this in more detail later on, but just to kind of give you some sort of idea of what we'll be talking about, there's something called Newton's cooling law. So Newton was curious about many things. One of the things he was curious about is how things cool down. And he noticed that the hotter something is, the faster it actually cools down, right? So he's actually there. Now this isn't something that you can derive mathematically. This is something that it's an empirical fact, right? You just pretty much, he sits there and measures the temperature or something, and he's tracking how the temperature is changing. And you realize that the temperature drops are larger when the object is hotter. And so he actually developed an equation that actually describes how this actually works. And it turns out that the cooling for most substances is actually linear. It turns out that, so that might be one way to actually look at the fact. So you might notice the hotter things are, what if the thing is actually colder than the surroundings? Probably a better way is to say something like, the larger the difference in temp between an object and its surrounding, the faster the temp of the object So here's a fact that we can gain by just measurements. You're a scientist, you go out in the world, you start measuring stuff, and you kind of notice this fact. Now you might notice that in saying this fact, I use the word faster, which means I'm talking about some sort of speed, some sort of velocity, and Newton's a fitting example. He's the guy who packaged calculus for us in much of the way that we use it today. And so we already know one great way to interpret speed, or how fast something is moving, that was a derivative. In fact, the change is linear in proportion. So if I let big T of little t equal to 10 of an object at time t, basically what this idea boils down to, if you were to express that idea in a mathematical equation, here's how it would tend to look. T prime is going to be some constant times the difference in temperature between the object and the surrounding temperature. This is the ambient temperature, or surrounding temperature. Now, things work out nicely if we have a negative sign in front of here, which we'll probably talk about later on, okay? So, very simple example. You go out in the world, you start to study temperature changes between objects, and this is a fact that you can come across. And by you expressing that fact mathematically, you end up with a differential equation. More specifically here, because a lot of times we'll have a lot of variables all over the place, d big T over d little t can be expressed by this equation. And this is something that someone can figure out empirically. That's a true fact about the nature of our universe. It has a derivative in the fact. So now you might want to say, well, what if I want to go beyond talking about how fast something is? What if I actually want to track the temperature of the object without me having to sit there and write down the temperature of the object all the time? Maybe knowing this fact should be able to help me talk about the actual temperature of the object. It's nice that I have this scientific fact, but what if I actually care more about the T? How can we describe what is actually happening to the temperature of the object? So now you might want to be able to talk about what would T equal? Is there a function that I can figure out to describe the temperature of the object, the current temperature at time t? The process of doing that is what we call solving the differential equation. You have an equation that has derivatives in it, and it can come about through various means. This is just one example, but they're uncountable example. Not technically speaking, probably. But here is an example of an equation that has a derivative in it, but you might care about something in that equation that you don't want to talk about derivatives. You don't want to talk about it in terms of rates of change. You just actually want to know what's the temperature right now. Right? So you have to go from a situation where a derivative is present to a situation where a derivative is not present. So in other words, you want to transform a differential equation into an equation that's not a differential equation, that deals more directly with the things you want to measure. Right? That's the process to get to this thing, if possible. This is what we call solving the ODE. And again, I'll talk about this in more detail. I'll give you some more specific examples. So this is just to give you an idea of why this thing might be important. There are many things like this. In engineering and science, in all sorts of applications, there are many things that when we try to state a fact about the universe or about some problem that we care about, derivatives tend to pop up. And sometimes we want to be able to talk about the things that we're studying without talking about the derivatives themselves. And that's what differential equations is about. Now, we are going to learn to solve many, many, many kinds of differential equations in this class. And it might give you the feel that, oh yeah, so differential equations is just this thing that we can, yeah, you have a derivative, just solve it. Yeah. Turns out that in real life, it's really hard to solve these in general. Like most of the time we come up upon a differential equation, we actually don't know how to solve it. I'm going to talk to you about some of the situations that we do know how to deal with and solve it analytically. Sometimes we have to solve it through some sort of numerical means, some approximation methods, which can be as good as we want them to be, and I'll mention a little bit about that. We will even use power series to talk about differential equations. So sometimes you can't get to a nice answer. It's not always possible to bring it to a situation like this, but when it is possible, we like to get there, and that's what I will be telling you. So it's very important, highly applicable. Situations arise where you describe situations where you might describe some phenomena in terms of derivatives, and you might want to talk about the situation without derivatives. This is setting up a differential equation problem and actually solving the differential equation problem. And again, I'll get more specific about this, but I want to give you just an idea of what we're doing and why it matters. Now, with that said, let's actually jump into the specifics of this class. Hi, my name's Jhevon. Nice to meet you. Welcome to Differential Equations. So, that's my name, Jhevon Smith. Jhevon is fine. That is my email address. That is where students should contact me. Don't email me at any other email address other than this one. Or I might not see it in a timely fashion. That's my office hours, the hour right before this class. I will either be in one of these two locations, depending on what I'm doing. If you're never sure where to find me, you can always shoot me an email. This is my website. There are many like it, but this one is mine. Class website, that's the website for this class specifically, is here. You can get to this website pretty easily. You just Google Jhevon CCNY, and it'll probably be one of the first things that pop up. And you can go to the class website because on my page you'll see a heading that says Fall 2019 Classes. 391 will be one of those classes. That class website is going to be important because I will be posting a lot of important information there, including, well, an electronic copy of the syllabus for one, where a lot of these things will actually be hyperlinked and you can just click on them instead of typing them out. So a copy of the syllabus, I will also post there quizzes and answers to quizzes, tests and answers to tests, reviews for tests, any handouts that I might have to give out to you guys, I'll post them there. So a lot of information will be posted there, maybe some advice or announcements as well. The text that we'll be using is Boyson de Prima. It's a very common text to use for an elementary differential equations class, and I will mostly be focusing on the 10th edition. I don't necessarily recommend that you buy the textbook unless you want to buy the textbook, but you can actually have access to this textbook through multiple ways. So we do have copies at the library, we have copies at the tutoring center, which I will tell you about. There are copies in the math department. So if you're on campus, you can have access to the textbook. But in general, you won't need it because I'll tell you everything you need to know in order to pass the class. So I'll write down a lot of notes in general. And homework, while it's not from that textbook, you will use this textbook for extra practice. So I'll talk about how that comes out. Okay, so no calculators. We won't be using calculators in this class. That's the regular grading chart. You should know what that looks like. And by now, if you're here, you might be new, so let me just say, it's a departmental policy that the finals in a math class at CCNY is 40% of your grade. So I don't really have much choice in that matter. So the final for this class will be cumulative and it will be worth 40% of your grade. The other 60% will be broken down thusly. So first item, quizzes, that will be worth 15% of your grade and you will have a quiz every week. So pretty much on a weekly basis, I'll quiz you. The quizzes will normally not be cumulative unless it's incidental, and they will cover what I covered in the previous week. So pretty much the only time you're not going to have a quiz is if we're having a test. Right? I'm not going to give you a quiz and a test on the same week. I'm not a maniac. Okay, homework is also important. That will be done online. So actually submit the homework online through the WebWork system. It's a free system, and you'll have unlimited attempts in general. I'll talk about that in a little bit more. We will be having 2 in-class tests, non-cumulative, none are dropped, so make sure you come right So each is worth 15%, so that'll be 30% of your grade. Participation is 5%, mostly going to be attendance. I'll be taking attendance every class as well, so make sure you actually show up and you get 5% for free, pretty much. Okay. And as I was mentioning here, not only does this class feel a lot like Calc 2 in practice, but actually proficiency in Calc 2 is going to make it a lot easier. Chances are, if you're struggling with something in this class, your issues are at the Calc 2 level. It's not usually going to be at another level. And obviously, maybe if your Calc 2 is really bad, your algebra is messed up as well, but Calc 2 is where we're going to be, where most of the techniques needed for this course are going to appear. That might make a lot of sense to you because if we care about dealing with something that has a derivative in it and we want to get rid of the derivative, we know since Calc 1 that integration is one of the ways that you do that. So you would expect integration to be a very important part of this class, and it is going to be an important part of the class. So remembering all your integration techniques from Calc 2 is going to be important. I'm not going to be reviewing them, so your integration by parts, partial fractions, all that stuff. I am going to expect that you guys are all experts at these techniques. So that's good. No makeups or missed quizzes or homework, but if you have a very good reason for missing a test, we can discuss it. Just need to provide proof, and we're on to the next page. Okay, so attendance, pretty much considered mandatory, and I'm actually giving you credit for attendance, so do show up. It's very important that you show up and participate as much as possible. Some expectations, work ethic. Now, this is becoming, I'm gonna trust you guys that you have this under control because, I mean, it's differential equations. You're not new to the whole math thing. You're not new to math at the college level. So you kind of know what it takes to pass a math class if you're here. So I'm going to assume that all of this kind of goes without saying, but I like to say things like without saying anyway. So expect you guys to work hard starting day one. Don't slack off, don't put things off. Deal with things as they arise. And I'll talk about a little bit more about how to do that coming up.
Thank you.
Prerequisites, yes. Remember all the math you've ever done, especially in Calc 2. Be responsible and mature students. Okay. I'll probably talk about that a little more as time goes on as well. And again, I'm just breezing through the syllabus, but you guys really should read this in detail. It's going to give you an idea of how the class is going to be run. Now, here's more specific information about the homework. And I'm pretty sure, I'm using WebWork for several classes, but I'm pretty sure for this class, I already actually put up some assignments here. So here's the instructions on how you'll access the homework system. So you'll go to this link, or you can go to the syllabus and click on that link. Your username will be the same username for your CCNY email, and it will always actually be the same. So if you ever change your CCNY email password, the password for this system is going to change. It's linked to your CUNY account. So you log in, and there are instructions for logging in here. Once you log in, you'll see the list of assignments and the due dates. Make sure you complete the assignments before the due dates. You'll have unlimited attempts to do so. So there really should be no reason for anyone not to have 100% on homework here. Right? So that means you now have 15% in the bag, in theory. Okay, so that's good. I'm giving you 15% pretty much for free for doing stuff that you should be doing anyway, homework and showing up. Now, these are blasphemies. Now again, I get really animated when talking about this in like a Calc 1 class, but I would assume you guys, again, kind of know the rules. Some very basic mistakes that I do not expect you to make. I call them blasphemies just because it's more inflammatory. It'll get people to pay attention. One, I'm just going to run through these quickly. Don't cancel cross sums. Happens all the time. Maybe you're working on a problem. Eventually you get to a point where you're like, okay, it's 2x plus 1 over 2, and you're like, I can simplify by canceling the 2's. No, you cannot cancel the 2's. You cannot cancel the 2's. That would be very wrong. The reason why it's wrong is because you cannot cancel across the sum, because there's a plus sign here, or a minus sign will also work, makes this incorrect. So don't do things like that. You can only cancel across multiplication or division, so if you had something like that, of course now you can cancel across the 2's. Second quite trivial mistake, but we'll make it all the time. Don't distribute powers across 6. So what this means is if you have something like x plus 2 all squared, I do not expect you to go, oh, just put the square root of these 2, so x squared plus 4. No, it is not x squared plus 4. That would be wrong. What's x squared plus x plus 2 all squared? Which, again, that's like x plus 2 times x plus 2, and you can multiply out. Or you can remember that a plus b all squared is a squared plus 2ab plus b squared. And if there's a minus sign takes effect in the middle. Another common way this catches students is with radicals. So a lot of times I'll see this happening. That is incorrect. In fact, that one is much worse than this one, and here's an audience where they'll actually get it when I say. So here, doing this wrong, you miss one term. Doing this wrong, you miss an infinite amount of terms. I assume everyone here knows that to expand a radical as like a polynomial, you need an infinite amount of terms. You learned that in Calc 3. So that's very wrong, but it happens a lot of times. Students just get scared and decide to get rid of a radical because it scares them, it looks ugly. Don't fall into that trap. So when we're dealing with the real numbers, these things are very bad. For some of you here, you're going to go into classes like abstract algebra, and there'll be times when these things actually work, but for us in the real numbers in calculus, they do not work, and you should not make that mistake. 3. Don't divide by 0. I know, I've seen it happen, so just want to mention that. 4, use your parentheses. And again, this is kind of something that I do expect most of you to appreciate in general. Learn and obey proper notation. And convention. As you guys probably know, a lot of times there are a lot of surprising things that causes people to do well that most people just don't realize. Something just like being neat and paying attention to notation can save you from so many mistakes, it's not even funny. Right? A lot of people think to do well in a math class they have to be some sort of genius, but no, you just have to kind of obey the rules. And that's it. So be neat, use proper notation, don't write things down when you mean to write them down. If there should be parentheses there, write it. Don't just in your head know that the parentheses should be there. It usually doesn't work out in an exam setting because when you're anxious, you'll forget all these kinds of things. So that's the typical thing. Some more, a little bit of higher level things. Some things that we should not expect on the calculus level. So if you're Calc 1 or below, these are mistakes that students make all the time, which is why I went through the trouble of listing them in the syllabus. A little bit higher is that you should remember that derivatives and integrals do not distribute across products. You need the product rules or something like integration by parts or substitution. So if you have something like the integral of x times e to the x dx, and you just, oh, let's integrate that, that's x over 2, that's power. Integrate this, that's e to the x plus c. No, that is wrong. It's not how you integrate x e to the x. How do you integrate x e to the x?
Integration by parts.
Integration by parts, how do you do it?
Use x.
Huh? Anyway.
Make like a u and v, and
U and?
and v, or
du.
dv,
Who's the u, who's the dv?
with e to the x as u.
How do we choose?
X is the x.
Why? How do you choose?
It will be du will equal 1.
Well, u would be x, dv would be e to the x, dx. The easy way to know how to choose is Liate. That's something you should remember for Calc 2, that might ring a bell. Logs, inverse functions, algebraic, which means polynomials, trig functions, exponentials. Whoever is higher in the list gets to be the u. Here we have an a and an e. A is higher in the list than the e, the a gets to be the u. Right? So now you find the du, which just becomes dx, you would find the v, which is e to the x, and you would plug them into what's the formula?
Minus e equal pd.
uv minus pdu.
Right, so it's u dv is equal to u times e minus the integral of du, and you actually plug that in. So you would just actually have x e to the x minus the integral of e to the x dx, which will give you x e to the x minus e to the x plus c, and that is the
I have a question.
integral. Yes.
What does that stand for again?
Liate.
Yeah.
Logs. Inverse functions, particularly inverse trig, algebraic, which is a misnomer, but it really means polynomials. But lipted doesn't have the same ring to it, so people put the A. T stands for trig, and E stands for exponentials. So if you want to use integration by parts, that's how you choose the parts. Use Liate. Okay, so things like that I don't expect you to do. Also things like you should know that the integral of 1 over something, what's that? You actually don't know. It's a function. But a lot of people think of 1 over something, they automatically think ln. This is not true in general. This only works if f is linear. Right? So you shouldn't have an ln with 1 over. So if you have something like integral of 1 over x squared, that's not the ln of x squared, which I see all the time. You'd actually just rewrite it and then do the power rule. So that's that. Yeah, those are the mistakes. Okay. So I don't expect anyone to make these mistakes. If you make one of these mistakes, I will give you a 0 for the problem. I will ignore everything else you write. Okay? Don't do one of these. So those are the last ones. They have very bad consequences. At some point, you need to raise the level of mistakes that you make. From now on, it is raised, and if you make one of these mistakes, I will punish you heavily for it.
Are we going to deal more with definite or indefinite integrals, or do we do both in this course?
We'll do both. It's a mixture. It's mostly indefinite, I would say, but it's by a slight margin. Also, remember the plus c when you're doing an indefinite integral. That is important. Okay, so contact. I will get all your email addresses by whatever email is in your CUNY First account. So, and it's very important that I am able to contact you via email. So if that's not the best email to reach you, you should actually email me and let me know your preferred email address. So if I have to send out any announcements. Also, I will be sending out links where you can see your report card so you always know how you're doing the class in real time. So you'll see my gradebook. I don't like using Blackboard, so I just use another third-party system, and I'll have to send you the link where you can actually address that, as well as anything else that's important. So I will either be contacting you from my email here, or the system that I'll be using to have hold your grades is called Jupyter Grades. So if you see an email from Jupyter Grades, chances are that's me, and so you should make sure you read that. Okay, feedback, very important, highly encourage feedback. So this is a two-way relationship. I'm here to teach, you're here to learn. We need to make sure that the communication between us is good. So don't be afraid to offer some constructive criticism. As long as it's constructive, it's fine. You won't be downgraded for it. Just make sure it's constructive. So don't just be like, your teaching sucks. Be like, your teaching sucks because. Here are some things that I think you can do. Help, if you ever need help, which it might happen, you have tons of resources. First there's me, you can see me during my office hours, or email me to kind of set one up. The websites I gave you, I will be, again, uploading a lot of things that will facilitate you in your study, and I'll also upload a lot of advice on how to use these resources that I'm giving you. Free tutoring is available in the Marshak building. That's the building across the street, the tall building on the 4th floor. I believe the first day is September 3rd, and the schedule is usually Monday through Thursday is 12 to 5, and Friday is 12 to 4. But you can go to this link to find out more information on that if you want to get personal tutoring for free. A lot of online resources, a lot of you probably know about a lot of these already, like Wolfram Alpha, Symbolab, Desmos, Graph, TK. Even I use those like all the time, so you can use them as well to check your work. A friend of mine was giving away free math help on his Twitter account for a while. I don't know if he's still doing that, but you might want to check him out if you want to. As well as your classmates provide a very good resource. So it's actually a very good idea for you guys to get the contact information of someone else in the class in case you need to form a study group or get some missing information or whatever. Disability services. So if you think you might need accommodations to perform in this class on an equal footing, you should contact these people as soon as possible within the first week of class, because a lot of things have to be put in motion for you to have that. Usual class rules, no cell phones, no disruptive behavior, no eating, drinking, it's fine. The usual academic integrity statement, don't cheat, don't like it. You'll get in a lot of trouble if I catch you. And the usual advice. A lot of it sounds pretty cheesy, like believe in yourself, but it's actually very, very important. And that's, probably talk more about that. I find that a lot of students, whenever they like get a bad grade or something just doesn't go well, they get down on themselves and they never actually put in more effort. So not doing something like that actually causes a lot of students more pain than they need to go through. So when things aren't going your way, the answer is to push harder. It's not to give up. Right? So things like that you should be aware of. Some important events that were selected from the academic calendar. You can go here to see the full academic calendar. You'll notice here that the last day to withdraw is November 5th. Your first test will be before that, as well as you'll have a bunch of quizzes and homeworks before that as well to kind of know how you're doing in the class. Final exam is going to be during this week. Now, as for what we will specifically be studying, it is in the topics list on the next page. So these are the sections in the textbook that we will be going over. And these are problems in the text that you can use for extra practice if you think you need that, which you probably should just get into the habit of doing most of these anyway. But yeah, I'm not going to collect these. These are more to facilitate your own study, so you kind of know what kind of problems to focus on and what is considered important for this class. You will notice that exam 1 will occur around here. The date is more fixed than the list of topics, so even if I don't finish everything here, at whatever we get up to by October 3rd, I'm testing you on it. So the first test is October 3rd. 30th. Sorry. So it'll cover as much as this as we get through. So I'm hoping to get to 3.8 at least by that date, but even if I don't get to that, I'm giving you a test anyway. And then we'll cover all this stuff, and then exam 2 will occur on December 11th. It'll cover everything that exam 1 didn't cover. So the tests themselves aren't cumulative, but your final exam is cumulative, and as far as I know at the moment, the final exam schedule is still a bit tentative at the moment, but my best guess for when your final is May 8th. That should be December 18th. I'll actually double check that. So just put a circle on that to make sure that I should be updating you on that. This is the usual course learning outcomes for accredited, so you should be aware of that. And the last page is a questionnaire that you can actually fill out and then attach it and then hand it to me in the class.
Okay, what's the
Huh? I think it's December 18th. But again, the final exam is schedule is still a bit tentative, so if any updates, I'll update you guys early.
So wait, what is the department final or your final?
The final is my final. So departmental finals only happen to classes that begin before 6 p.m. So I will write and grade your final. So test 1 and test 2 should get you used to how I write problems, and hopefully that will translate into you being more prepared for the final. Other than that, any questions?
Yeah, about the quizzes in general, is there a way that they're like organized every Wednesday, for example, like at the beginning of the period, or?
Usually it'll be like at the beginning of class, at the beginning of the week, and I'll test you on what we did the previous week.
Okay, so like every Monday, usually?
Yeah, something like that. Unless we're not here on a particular Monday. Other questions? And the quizzes will mostly be like short answer, fill in the blank type stuff. That way I can grade them and get them back to you quickly. But tests, you will have to show all your work, and I'll be grading you with partial credit. Any other questions?
You know when the first quiz is going to be?
Yeah.
Would you like to share that information with us?
I will, yeah. So, but it'll usually be at the beginning of every week, like the first class of every week. Other questions? Yeah, so quizzes aren't something I'm going to be announcing. You should just expect that the first class of every week, I'm going to be tested somehow. Other questions?
What did you study?
Math.
Did you have a specific field?
No, I kind of just dabbled around.
Was math hard?
Well, not what I did. So, I don't know. But some of it is hard, yeah. This class, it shouldn't be hard though, so don't worry about that too much. Like I said, it should feel a lot like Calc 2. If you were awesome at Calc 2, this class shouldn't be a problem. Other questions? Give you guys a couple minutes to finish filling those out, and then we'll move on. You can wait to give me at the end.
Isn't it D9 has a notice? D9 is supposed to.
So,
Pretty sure there was that thing for what was it? Subscribe to my YouTube channel. Oh, I don't have a YouTube channel.
okay.
Yeah, Winham,
Yeah,
Winham, what's your address again? Winham, what's your address again? One more time, I didn't quite catch that.
So, to answer an earlier question, actually came prepared to give you guys a quiz today. But I don't think we have enough time. So I'll probably push off the quiz today for next week. So you guys actually escape today. So the quiz next week, it's gonna be purely like Calc 2 and below, just to make sure you guys remember certain things. So make sure you take this weekend, review things like your integrals and solving equations. Because that'll be what the quiz is on next week. So I'm going to ask you a bunch of integrals, ask you to solve a bunch of equations, make sure you remember your algebra, you remember your Calc 2. Other than that, I think we're pretty much done unless there are any questions.
Question about the quizzes, are they going to be really short or like, I'm just wondering.
Usually like 15 minutes-ish, and the length of the problems would depend on the difficulty of the topic. Usually if it applies, I will test you on like general formulas that you need to know. So if this was an algebra class, like problem 1 might be, do you know the quadratic formula? You know, like general formulas, ideas, and definitions are often tested, and then I'll give you a few more examples where you work through specific problems. That's kind of going to be the format. Yeah.
Are the homeworks already set up?
A few of them are, I'm pretty sure. So make sure you can actually follow those instructions and you can actually log in. If you can't log in, just email me and let me look into it. But the roster should be loaded in the system already, so you should be able to log in right away. I already think I opened the first couple of assignments. So go home, prepare for your quiz next week, and I will see you start differential equations.
My God.